Yeah, today our lecture deals with arrays. Now, before starting off with arrays, let us briefly see some of the concepts of casting for in case of data types. Now, as we have seen the different data types that we have in Java, we have byte increases towards short, then towards int, then towards long. So this is the direction in which we have increase in size of the data type. So long has the biggest size 64 bits, int 32, then we have short 16, byte we have 8 bits. So this is the reverse is the order in which we can assign data types. For example, in case we have a long variable, we can assign a to a. Now what we have done essentially is that a is the variable of data type long, whereas AA is a variable of data type int, which is smaller in size than long. So we can assign AA to A. So what we have essentially done is, this is the order in which we can assign the values. Byte can be allotted to a short, short can be allotted to a int can be allotted to a long, and anybody else also. Byte can be allotted to int, byte can be allotted to a long. However, the reverse, let us see what happens when the reverse allotment is done. Now in case we allot a long to an int, so this is a long value, this is allotted to an int. Now because int is 32 bits and long is 64, this means the 32 bits from the long have to be removed to get this data type. So that 32 bits that we remove may carry some data, so there's a chance of a data loss, so which we don't want intentionally to happen. So what we have to do here is an explicit cast to int. So what this has done is that we are specifying that we want to reduce the type of this a from long to int, and then assign this to the int variable AA. So in this case, it, because of this explicit cast, we are aware that there might be a data loss, and our program is fully prepared to take such a data loss. So in the reverse order, in case we assign a long to a byte, or we assign a long to an int, or a long to a short, we have to explicitly mention the cast into which we are casting this higher data type to a lower data type. Now the second important point in this case is, I'll just remove this, that all calculations that we do, they cannot be done below a int scale. So I'll just take a byte, give it initial value 4, take another byte, give it initial value say 4, and we compute an addition of these two variables to give a result in byte. Now even though the addition of a plus b gives us a value of 8, which is well below the highest value that can be assigned to a byte, yet there is an error, and the error is that it cannot convert an int to a byte. Now what exactly happens here is, the a is converted from byte to int, which we call as automatic cast, as it is an upcast, because byte is smaller in size than an int, so you can always cast a byte to a int. Similarly, the system has cast b from byte to int, so this becomes int plus int, so the net result comes to be an int. But because we are storing this result in a byte, so system is not able to downgrade the int to a byte. So this calculation it is able to do in the int scale because it is able to promote a from byte to int, b from byte to int, but the result it is not able to store in a byte variable because it is not able to downcast the result from int to byte. So for that we have to downcast the result by an explicit cast from sorry int to byte, and that should do it. So the error has now gone. Now what is happening is a promoted to an int, b promotes to an int, the result becomes an int, but since we are storing this result into a byte, we have explicitly mentioned the cast to be done from an int to a byte, and this is how the program simplifies and compiles. Then we can run and see the output. So we'll just run this. The output comes out to be as expected 8. However, in the absence of any casting, the system shows an error because when it does any calculation, it promotes every variable to a minimum int in case it is smaller than an int, and the result shall always come as an int. So we'll just move forward to the arrays part now. Now as we had already done variables where every variable stores a single value, now in case of arrays, now every variable now stores a number of similar values. Similar value means, now let us just see the declaration part. Now how do we declare a one-dimensional array in Java? So we'll just take the type, name it, give the dimension, new, int, and then we give the size of the array. So this is a static declaration for an array. So where int is the type